In this equation, we have what is considered a multiple angle. 2x is a multiple angle because it's 2 times x. All the equations that we have solved previous to this have just been cosecant of x or sine of x or cosine of x. The strategy that we're going to use for solving this equation is we're going to actually solve for 2x, and then after we get that solution, divide our answers by 2. So solving for 2x, we would have the cosecant of 2x is equal to 2 over the square root of 3 if we add 2 square roots of 3 to both sides. And so cosecant is the reciprocal of sine. So if we think about our special right triangles, cosecant would be hypotenuse over opposite. The third side of the triangle would be 1. And so the triangle that this matches up to is a 60-degree triangle, which means our reference angle in radians would be equal to pi over 3. So cosecant is positive in the first quadrant, and then cosecant is also positive in the second quadrant. So our first quadrant answer for 2x would be equal to pi over 3, and then we want all the angles coterminal to that, so we would add 2 pi in. And then in the second quadrant, our 2x would be equal to, if you have a reference angle in the second quadrant of pi over 3, you would subtract that from pi to get 2 pi over 3. So our second quadrant angle would be 2 pi over 3. And then to get the angles coterminal, we would also add plus 2 pi in. And so those would be our answers if we were only searching for 2x. But we're actually trying to find the answer to x. So to get the answer for x, we would have to go back and divide the parts of our equation by 2. Pi over 3 divided by 2 would be pi over 6. And 2 pi n divided by 2 would be pi n. Same thing for our second quadrant answer. If we go through and we divide by 2, 2 pi over 3 divided by 2 would be pi over 3, and 2 pi n divided by 2 would be pi n. Of course, this is where n is an integer.